Hello, can you hear me now?
Hello.
Hello, can you hear me? Okay. Can you hear me, right?
Yes.
Excellent. Now, this will be our last class for this semester. So after this class, you're not gonna see me forever. Okay. So let me use the opportunity to tell you what to do, what you are required to do. I'll take you to the announcements. All right. Week 16. So you just complete the remaining homework and your project. Then classwork 11. As a matter of fact, classwork 11, let me show you what it is. It's not really a big deal. You see it in module 8, sorry, module 8, and module 7, this right here. What I require you to do there is to watch this video on simple linear regression and correlation and multiple regressions. So when you finish watching the video, just write a brief something that explains what you learned about simple linear regression and multiple regression and correlation. Now, also keep the video handy because your last assigned homework will be based on these two videos. So, so you watch the video while you do this homework, the last homework, which is 10, I think it's homework 10, I believe. Okay. A matter of fact, what we're doing today, the last two homework will be based on that. So just watch the video, right? Your answer will include the regression equation for each of the two sections of the video. That is for simple linear regression and for multiple regression. And then you submit it, for grading. Now, having said that, I want to tell you one more thing before we begin. Um, on Sunday night, I'm going to open your final exam. I hope you can see the screen. It's right here. I'm going to open it on Sunday night. But in the meantime, you can start working on this one here, which is the practice exam for the finals. Okay? It says at 6 points, but actually it doesn't worth any point. It just I don't know why they put it, the Pearson put it there. But this one I'm gonna open. So then remember to your project. Submit your project. I think I put the project okay right here. Because some of you have submitted it. So that's good. So let us round up. We started test of hypothesis last week. I introduced you to test of hypothesis and how to state hypothesis. Now, we are going to finish it today. Let us take a quick look at some of the terms we use when we test hypothesis. The first one is this significance level. The significance level, I'm not sure. Yeah. Okay. Oh, I gotta put this right here. Okay. Now I'm going to give me 1 minute. I'll find something. 1 minute. Okay. Minimize it. This escape, not escape it. Anyway, let me just take you to that place. Get back here. So We start with the level of significance. The significance level is simply the probability of committing a type 1 error. That is rejecting a correct, that is rejecting the null hypothesis when it is true. So the probability of doing that, we call it the type 1 error. We call it the significance level, alpha, which is the probability of rejecting the null hypothesis when it is true. So critical region simply means the rejection region. So if your answer falls in the critical region, you reject it, the null hypothesis. But if it does not fall in the critical region, you don't reject it. And critical value is the cutoff point. It's a value that separates the critical region from the non-critical region. Simply put, it is the point on the test distribution that is compared to the test statistic to determine whether to reject the null hypothesis or not. If we usually use it as an absolute value, in general, if your answer is bigger than the critical region, you reject null hypothesis. If it's not, if it's less than it, I think the best way to say it is if your answer is equal to or greater than the critical region, you reject the null hypothesis. Otherwise, you don't reject it. Now let's look at types of tests we normally do. There are two-tailed tests, in which case the critical region is in two sides. You can see from this the chart I have on the screen. This is the non-critical region. If your answer fall within this region, you don't reject. But if your answer fall in any of this blue section that have the critical region, you reject the null hypothesis. And because that rejection region is two of them, there are two of them, we call it two-tailed test. Sometimes the critical region might fall in the left side only. We call it left-tailed test. And when it falls on the right side only, we call it the right-tailed test. Now, before we begin the test, I want you to know how to find the critical values, both for the two-tail and left-tail. Okay, for the two-tail, we did it something like that when we were doing confidence intervals. I put the formulas, except from actually you can use a table to do it as well. But the table for this class we're using the Excel, so I put the chart here for you. You can use it I recommend you to print the chart and keep it handy whenever you're trying to find the critical value. So we'll be using it for this class. Let's try the first one. It says find the critical values, find the critical Z values for this for each situation. A left-tailed test with alpha 0.10, a two-tailed test with alpha 0.20, a right-tailed test with alpha 0.005. Let me add more to it. Oh, excuse me, sorry, my mistake. Oh my God. This happens sometimes. I don't know why, but I'm gonna put it back. Don't worry. I'll put it back. Okay, hypothesis testing. Okay, I'm gonna close this one. Let me share it again. So that we go back there. Yeah. Okay. So, like I say, we'll be using it in a minute. I wanted to add more to this list. So, D, add D, a right-tailed tests, uh, 0.05. Then add another one. left tail. Left tail test. Alpha. We call 0.01. Okay, 0.01 is again the two-tailed test. Okay, a two-tailed alpha 0.01. Let me put that this way. So that by the time you finish it, you'll be familiar with how to do this. Get a piece of paper. I'm gonna use the back of this. So what I'm gonna do is to write these things. I'm gonna write this in Excel. Okay, I'll take it to the Excel. Okay, critical values. I'm gonna copy this. Okay, all right. Left tail, right tail. Okay, I'm gonna move this a little bit down. Okay, so the other one we have is we have right tail test for alpha 0.01. Okay, right tail, tail. So the first one we had is alpha 0.10, 0.02. 0.10, 0.02, 0.005. Then I added these new ones. Left tail, two tails for 0.01 for each of them. Okay. Okay. So I'm going to add these things here. So I then ask the person. So I'm going to type the formula for each of them. So you can see the formula we are using. Good. I'm gonna put it in a box. Okay. Critical values. Critical values. Values formula. Okay. Right there. The formula is what is the formula? Okay, right here. Right there equals norm dot s dot inverse. Okay. Then alpha. Alpha. That is for right there. Let me make sure I see this. Yep. For left there, left there. It will be equals norm dot s dot inverse 1 minus alpha. Oh, actually, this one is left. The first one is for left tail. Left tail. This one is for right tail. Right tail. 1 minus alpha. We have here 1 minus alpha. Okay. Then for 2 tails, okay, you're gonna be num dot s dot inverse. Okay. 1 minus alpha over 2. Alpha over 2. So let me add one more here. 2 tails. And make alpha to be 0.05. So let's get the critical values. Okay. So the first one is left tail. Left tail. So it's gonna be equal, says num dot s dot inverse alpha. Not num dot s dot inverse. We're going to say alpha, which is 0.1 in this case. Then press close parenthesis and press enter key. Get the critical value right away. Then for right there equals num dot s dot inverse 1 minus alpha. Okay, close parenthesis. That will give you the critical value. Then for 2 tails equals num dot s dot inverse 1 minus alpha over 2. Then press the enter key to give you the critical value. Now for this one, which is right there, equals num dot s dot inverse 1 minus alpha, close parenthesis. See, very easy. For left tail equals num dot s dot inverse alpha, close parenthesis. Then press enter key, give you alpha. And then for 2 tails equals num dot s dot inverse. Okay, 1 minus alpha over 2. And give this. So you can this one, because this is the second one is also 2 tails. You can just copy this down to calculate the rest of that. Now you can make it. Usually we leave it at 2 decimal places, so you can make it 2 decimal places. That's it right there. Guys, any question on this? Any question?
No questions.
Good. So this is how to find the critical value for Z tests. We're gonna do the one for T test when we start doing T test. Now we're ready to conduct the test. Look at the Z test for the mean. There are 2 methods. Either you use the traditional method or you use the p-value method. The good news is that Excel result will give you both the answer for the critical value method, the traditional method, and for the p-value method. So if you're using an Excel, you are good. And then the principle and step are almost 90% similar. First of all, you state the hypothesis and identify your claims. Excuse me. Then you find the critical values from the appropriate table. Then you compute the test value, or what you call a test statistic. Then your answer you get from the test statistic, you compare it to the critical value. If your answer is equal to or greater than critical value, you reject no hypothesis. But if your answer is less than critical value, you don't reject. Now, if you're doing a p-value method, it is the opposite. If your answer is equal to or greater than alpha, you don't reject. But if it's less than alpha, you reject. Let me show you where I wrote the criteria for. This is the criteria for traditional method. Reject null hypothesis if the calculated value is equal to or less than the critical value. But for the p-value method, uh, the criteria for rejection is as follows. Say, if your p-value is less than or equal to alpha, then reject. But if it's greater than or equal to alpha, don't reject. Let's do an example. Okay. Do an example. It says here that yeah, so for some reason whenever I come to this side, it will block up. Anyway, let me put it right here. I'm bringing it down with this. I'll take this one down. Okay. It said a researcher. Okay, good. A researcher. It block it stop again. Okay. So a researcher report that the average annual salary of assistant professors in 1997 is more than $42,000. A sample of 30 assistant professors. A sample of 30 assistant professors claim that that they earn more than 42,000 a year in 1997. The standard deviation is of the population is 5,230. It's a test the claim at alpha 0.05, test the claim that the assistant professors earn more than for 2,000 a year in 1997. Now, the test statistic we use is this formula here. Z equals X bar minus mean divided by the standard deviation over the square root of n, where X bar is sample mean, mu is the population mean, delta is the population standard deviation, and n is the sample size. Now, but that is if you are using a regular calculator. But if you are using Excel, you don't need this formula. Excel will do the work for you. But let's just state the hypothesis first. HO, I showed you how to do this last week, and H1. Now we're testing for the mean. Said, test the claim that assistant professors earn more than 42,000. That's the key word right there. More than meaning, it means greater than symbol. And you can only use the greater than symbol in the alternative hypothesis. So I'm going to put the formula mean, okay, then greater than. I'll make this in 18. So mean is average salary greater than 42,000. Okay, that is the claim. Okay, then the null hypothesis will say the opposite, mean less than. But the problem is that we cannot use less than symbol in the null. We can only use less than or equal to, or we can use equal to. So you gotta be mean less than or equal to, okay, 42,000. And the alpha we are using is 0.05. at the significant level. Okay. Now, let's put the numbers in. X bar, you say a report that a researcher report that the average annual salary of assistant professors, that is for the entire population of assistant professors, that the average annual salary is 42,000. I mean, in 1997. Okay. So I'm going to put mean equal 42,000. Okay. So how do we put mean equals 42,000? So I'm listing the values now. And then the standard deviation is 5,230. So I'm going to put standard deviation right here. Standard deviation is 5,230. So that we have the that one. The population now they sample the 30 assistant professors and found that the average salary is 43,260. That's our X bar. Our X bar. X bar equals 43,000, 43,260. And how many of them did they sample? 30 of them. So our N is 30 assistant professors. So we are asked to test the claim that the assistant professors earn more than that. So let me write this thing down so we can now go to the next, so that we can go to the next page and get this thing done, to Excel and get this thing done right away. We have a hypothesis stated, and we can now do this. So I have alpha is 0.05, mu is 42,000, X bar is at 43,260. Standard deviation 5230. Then sample size n is 30. Let's go and put this in Excel, get our results. Now, Excel does not have it doesn't have the function for one sample z test. One sample z-test. So, but it only have for 2 samples. So, but we are going to trick Excel to do it anyway. Now, first of all, let's look at our since there are 30 of them, I can just put the 30 observation will be 1 to 30. Okay? Because 30 were sampled. I'm gonna put those things that I typed in here. Pressure mean is 42,000. Okay, sample mean is 43,000. 260. Population standard deviation is 52. Okay, 30. Now, we have sample size 30 of them. Okay, and alpha, we are told that alpha is 0.05. Okay, now, so because there are 30 of them, I'm going to write 1 to 30. So I'm going to just highlight the 2 of them and copy the 30. Okay. Okay. So now, then sample mean. Now, because this is a summary statistics, normally I said deal with raw data, but this one they give us summary statistics. So we can just use sample mean that we have, which is 43,260. Put it for assign it for each of these numbers. 43,260. Okay. Copy it all the way down. Double click it to copy the whole thing down. Excellent. Now, like I told you, Excel doesn't have the function for one sample z-test in the Excel the 2-pack. So what I'm going to do, we are going to trick it. So we're going to trick it and make it believe that this is a 2-sample test. How do we do that? Just put 0. 2 0. So Excel will now look at it as a 2-sample z-test, but because we have 0 here, it won't affect the result. Now let us run the test. To run the test, okay. To run it, just go to data. Let's go to data. Just make sure I've seen this. Yeah, I see it. Click on data analysis. I can see right here. Scroll all the way down. You can see where you can see that you see 2-sample z-test. You can see I have the z-test 2-sample for means. Click on that. Then click OK. Now for the for the variable 1 range, you use the data here. Okay, I like all the way to the end. Got everything. For variable 2 range, in that case, you use a dummy variable. Okay. Now, hypothesize mean difference. That one is the sample population mean. You can see right here. It's a 42,000. Put 42,000 here. Variable 1 variance. So Excel don't have standard deviation because we are giving standard. It doesn't have it. I mean, for this test. So we're gonna get the standard deviation of this number. 52 days. So let's see. Let me write it down because it won't allow us to put it here. 52,5230. Let's get the standard deviation. Let's get the variance. You know that variance is the square root of, variance is the standard deviation is the square root of variance. So that the variance will be the standard deviation squared. Because that's what it's asking us here. It's asking for the variance, which is variance 1 for this. So let me see if I can get a calculator for this. Why is that calculator? Okay, right here. So we're gonna do the calculator. I got 5230 and the variance. I'm gonna square it. It give me 27,352. 27,352,900. Okay. So I'm gonna put it there for the variance. What's what is asking for variance? Okay. So you have the can you see the Excel dialog box? Okay. So I'm gonna put 42, 27, 352, 900. Okay. Now the for the variable 2, for the dummy variable, you just put a small, because remember we are trying to trick Excel to believe that this is a 2-tailed test. Put a very small, you can put 0, but Excel will not accept 0. Put a very small number that is so small that it will not affect the result. You can put 0.00001. And since we are using luckily for us, we are using the alpha of 0.05. So we are good with that. It's a label. Since I checked I highlighted the labels, so I'm gonna check the labels. The output range is where you want it to be. output range is where you want it to be. I can choose output range here, where I want it to be right here. Okay, put right here. Okay. Output range is where you want it to be in Excel. I put one here. I can choose to put it right here under this place. Okay. Then once you have that, then you can click OK. Okay. It will show you the results. What is the result? It showed us the result right here. So once I click OK, it showed us the result right here. As you can see, now I can just delete the dummy variable. Delete it. Okay. Now change this to one sample. One. Okay. Now I can do that. I can then highlight it. Highlight the whole thing. Okay. Control C. I can even let me make it let me make the make it more bold. Highlight the whole thing, make it more bold. Then I can just copy this. Okay. And paste it right here in the Word. Or you can just leave it here. Let's just leave it here. Remember our null hypothesis. Let me refresh your memory. That mean is less than 42,000. The claim was that mean is greater than 42,000. So the Excel result give us everything. It gave us, let me make this size. Size would be 2 decimal places. So it gave us the because this one, from our null hypothesis, which says from our claim, which is on the alternative, say that the mean average salary is greater than 42,000. That means it's pointing on the right side, so you can call it the right tail test. So you can see that Excel give us the test statistic, which is right here. Now, it also give us one tail. Give us this is the one tail Z for one tail critical value. Now, if I'm using p-value, you use this one for one tail. I'm gonna make it green. And then if it's two tails, use this one. Anyway, let us just do this. We're on one tail, so I'm gonna just from this I can now say if you like, I can leave it here. I can just copy this, paste it in the word so we can compare our this thing and make our decision. I'm gonna paste it here. Make it a little bit bigger. Okay, because of what is happening to that page. Okay. All right. Yeah, that page is I'll make it bigger. Good. So you can see that, okay. Now let's make our decision. Okay. Make a decision now. Okay. Calculated value, decision. Decision. Calculated value equals, that's how given is a 1.32. 1.32. Then critical value equals 1.64. So are we going to reject or not reject? Remember the criteria. Criteria says reject null hypothesis if and only if the calculated value is equal to or greater than the critical value. So if you're using the traditional method, that means you'll be using the critical value, which say that to reject if and only if your answer is equal to or is greater than the critical value. Let me make this in bold. So our answer is 1.32 and the critical value is 1.64. So our answer is less than the critical value. So we don't reject the null hypothesis. Do not reject the null hypothesis because the calculated value of 1.32 is less than the critical value of 1.64. So, but if your answer, let's say that your answer Z is 1.5, sorry, 1.75 or 1.65, which is bigger than this. In that case, you reject, but it's not. So, so our conclusion, so but in this case, it is less than, so we can't reject. So we are not rejecting null hypothesis, which means that we're rejecting the claim. Therefore, we can conclude that there is insufficient evidence support the claim that the claim was that the assistant professors earned more than 42,000 in the year 1997. Okay, there is insufficient evidence that to support the claim that assistant professors earned more than 42,000 in 1997. Any question, guys? Any question? Okay, no question. So that's good. I'm glad we are getting the picture. Now, if you're using the p-value method, let me show you what to do. If this is the traditional method, if you're using the p-value method, it's something except that now you make conclusion based on the p-value. Okay. Now, let me show you how to make decision using the critical p-value method. Instead of using the p-value method, p-value method decision. Decision. Conclusion. Decision. Yeah, decision. In that case, use alpha. Alpha is 0.05. Alpha is 0.05. Okay. Alpha equal 0.05. Okay. And our p-value that we have, you can see the p-value, okay, is 0.09. P-value is 0.09. P-value equals 0.09. Now, you can see that our for the p-value method, let me refresh your memory. For the p-value method, this is the decision criteria. If the p-value is less than or equal to alpha, reject. But if it's more than alpha, do not reject. In this case, you can see that our p-value is 0.09, which is greater than alpha. So we do not reject. Do not. Or 0.09 is bigger than 0.05. Do not reject. HO. And the conclusion will be the same. So now in each case, we don't reject. So if, whether you are using the p-value method or the traditional method, you still get the same answer in terms of the final decision and conclusion. So our conclusion will be the same, which is that there's insufficient evidence to support the claim that assistant professors earn more than 42,000 in a year. I mean, a year in 1997. Any question for me? Any question, guys? Okay, no question. Okay, excellent. Now, you can practice the rest of this by yourself. Let us take to a situation whereby the sample size is small and we don't know the value of the population standard deviation. In that case, we use the t-test for the mean. Okay. Now, the t-test for the mean is a statistical test that for the mean of the population, and we use it when the population is normally distributed or approximately normally distributed, but it's less than 30 as small populations. And the population standard deviation is not known. So in that case, the formula we're using is T equals X bar minus mean divided by the standard deviation. Okay? So let's look at this scenario here. The process is the same. State the hypothesis, identify the claim, get your significance level, and then run the test. Get the critical value, run the test. Then after you finish running the test, you compare the answer to the critical value. If your answer is equal to or greater than the critical value, you reject null hypothesis. Otherwise, you don't reject it. If you're using p-value, now if your answer is greater than or equal to the alpha, you reject just the opposite, But if it's less than alpha, you don't. It's reject, but it's less than alpha. Sorry, if your answer is greater than or equal to the alpha, you don't reject. But if it's less than alpha, you reject. Now, this kind of test is based on what we call degree of freedom. And we get the degree of freedom by doing the sample size minus 1. Then we use this t-test, this test statistic formula. Since we're using Excel, we use this formula because since Excel doesn't have the function for where we can use the formula we can use, unlike the one I just did, which is z-test. When you are using summary statistics, Excel doesn't have a function for that. But if you are using raw data, I mean, it doesn't have it either, but you can trick Excel to do it anyway. But in this particular one, when the data is summary data from the you can just you cannot use Excel to do it directly. Let us try an example. I want to show you how to find the critical value first for t-test. So for this one, I will take you to Excel again. Find the critical value. So for t-test, I'll say the question here says use the Excel to find the critical value for each situation. It's alpha 0.05 with degree of freedom of 16. Okay, alpha 0.01 with DF of 22. So let me write them down so that we can go and put it here. One is alpha equals 0.05, while DF of 6 The other one is alpha 0.01 df of 22, alpha of 0.10 df of 18, alpha of 0.05, and df of 28. Okay, this one you can get it faster. Or they have to they mention the for right tail. Okay, so the first one is for right tail. Okay, right tail is 0.05, and we got degree of freedom 6. The other one will be T for alpha. For 22 degree of freedom is left tail test. To left. The other one is two-tailed. This one is right tail. Okay. So left tail is 0.01 with 22 degree of freedom. Two tails 0.10 with 18 degrees of freedom. This first one is 0.05 with 28 degree of freedom. So this is the degree of freedom. I'm going to call it DF. Okay, now I can now create critical value right here. Critical value T. Okay, so the formula is for this one. All right, here I have it on the screen for you. Let me have this formula right here for you in this handout. Right here, you can see them all here. The examples. So like I said, I recommend you print them out. So I'm going to be using it now for this question. How to find critical value. Okay, we have let's do it. The first one will be equals num dots. Okay. Oh, actually, this one is so this is t value. So you're gonna be t dot inverse, t dot inverse. Also, is left tail. So it's gonna be alpha. Click on alpha, comma, and critical value. Okay. Sorry, the degree of freedom. Close the parenthesis, press enter key. Keep it right that way. Right there equals t dot inverse. Okay, 1 minus alpha. Alpha of this one, comma, and then click on degree of freedom. And close the parenthesis and press the enter key. Okay, let's give you that one. Two tails, so t dot inverse equal t dot inverse dot two tail, 2t. Okay, then click on alpha, comma, degree of freedom, close parenthesis. Okay, press the enter key. Okay, then for right there equals t dot inverse of t dot inverse. Okay, 1 minus alpha. Okay, comma, degree of freedom of 28. Press the enter key. So you can just make them 2 decimal places by highlighting and just changing them to 2 decimal places. That's the critical values we're looking for here. Let me make it answer that question. Okay, I just copy it and paste it there. Solutions right here. Make it 18 so you can see it. And move this here. Good. Answer the question. So that's how you can find the critical value for T test. Now we're ready to run the test. At least 1 test or 2 tests. Let's do 2. Okay. Oh, excuse me. They say a job placement director claimed that the average starting salary for nurses in year 2000 is $24,000. A random sample of 10 nurses has a mean of 23,450 and a standard deviation of 400. Is there enough evidence to reject the director's claim at alpha 0.01, 0.05? So he claimed that the average salary in the 2000 is average starting salary is the keyword. Is 24 is means equal. Okay. So we have our H0 and H1. Okay. I'm gonna make it right here. HO and H1 is so that was his claim that it is 2006 mean. Okay, mean equals to 24,000. That's the claim right there. The one is that mean is not equal to, that's the opposite you can use. Mean is not equal to $24,000. Yeah. So now we have our alpha giving us 0.05. Yeah. Now we can get some numbers down. We got population mean is 24,000. Sample mean X bar. That's a sample of 10 nurses. Sample standard deviation. Oh, S bar, sorry. S bar is for 10 nurses is 23,000. 23,450. Okay, for this one, for sample, because this is 10 nurses. So sample size is small, and we don't know the population standard deviation. All we know is the sample standard deviation of 400. So we're going to use sample, and we're going to use X, because it's not the standard deviation of the population. So we use X for it. 400. And sample size N equals, how many again? 10 nurses. Let me write this down so we can go and put them in. Since we have our, before I do that, since we have our excuse me, since we have our alpha and n is 10, so that our degree of freedom will be n minus 1. Degree of freedom here equals n minus 1, which is 10 minus 1. Okay, that'll give us 9. With that, we can find our critical value. This is equal and not equal. So it's both sides. It's two-tailed test. So let's go and find the critical value. Okay. And we can even do it on yeah. Find the critical value. Critical value T alpha over 2 T alpha. I'll call it critical value right here. I like to put it just behind below the alpha. Critical value T alpha over 2 T alpha over 2 equals T alpha over 2. Maybe we can get it from Excel. I just showed you how to get it already. So let's see. Let me write this in down so you can alpha is 0.05 and then degree of freedom df equals 9. Let's go and get the critical value in Excel. Okay. I have this one is two tails. Two tails. So two tails, I'm gonna use equal. I'm gonna put alpha. I'm gonna say alpha equals 0.05 and degree of freedom df equals 9 degree of freedom. So that the critical value T alpha over 2, T critical will be equals num dot s, T dot inverse, T dot inverse dot 2T. We have our alpha first, comma, then the degree of freedom, then close it, press enter key. So 2.26, make it 2.26. 2.26. So our critical value is 2.26. 2.26. Okay. Now we can just we have everything we need basically. Now we can use this formula for this to find the test statistic. The formula is right here. If you still remember, so here, I'll copy this. Okay, I'll move it back down here. So let's run the test statistic. Let's get a test statistic. Okay, statistic is okay. That's it. So let's get the normally I like to get the denominator of s over the square root of n. Okay, so I can say s. Let's get that part. So we have s divided by square root of n. Oh, we have our x right here. We have our x right here. Okay, s right here, 400. So I'm gonna say because the s is for 400, s bar is for 23,450, mu is 24,000. N is from 10. So x over root n, that means 10 over root n, so excuse me, s divided by square root of n, okay, square root of n, oh, excuse me, small n, becomes 400 divided by square root of 10. That means I'm getting the denominator right here. That give us you can get it from Excel. And get equals 400 divided by SQ RT, just square root of n, which is 10. Okay. Press the enter key, I'll give you an answer. Yeah. Enter key. 126.49. 126.49. Okay. 126.49. Now with this, we can get our test statistic. So our test statistic T becomes equals, there's a small t, not capital T, there's a small t. Okay, sure, I've seen this. Yep. Equals, we say S bar minus mean, which will be, S bar is 23,450 minus the mean of 24,000 divided by S root n. That means we got it as 126.49. 0.49. That gives us, we'll write this down so you can get it in Excel. I got T equals 23,450, okay, minus 24,000 divided by 126.49. That goes an answer. Let's go and put it in Excel. So we got equal 3,000 450. Okay. Minus 24,000 divided by 126.49. 0.49. 94.35. Negative 4.35. We round it. I'm going to round it right here. Yep, negative 4.35. Okay. Negative 4.35. I know this is a two-terra cell. That means it can be left side or right side. It is negative. That means it's on the right, on the left side. But what we are using, what we're actually using is the absolute value, which is 4.35. Because it's by symmetry, Now let us make our decision. Calculated value, calculated T, that's your answer. T equals, answer is 4.35. And of course, these are the critical value. Critical value. Okay. Value. Critical T value, yeah. Value, which is T half over 2. T half over 2. Two equals, we got it here as, from the cell as 2.26. 2.26. So you can see that the answer is bigger than the critical value. So we reject HO since the calculated T value, okay, is greater than the critical value, is greater than the critical value. Okay, it's greater than the critical value. So that's a conclusion. So we do not reject. You say reject. We rejected. So that means we rejected this. Okay, let me hold on. He said reject H. So that means we said we rejected H. I mean, we rejected this. That is the claim. We rejected the claim and conclude that it's not equal to. We say that it's equal to. That was the claim. So there is not enough evidence. We don't have enough evidence to support the claim that the salaries that the average starting salary of nurses in 2000 is 24,000. So we reject HO. So that means our conclusion, there is not enough evidence to support the claim, that the average starting salary of nurses in 2000 is $24,000. Any question on this? Any question, guys? Okay, since there's no question, so I would say try as much as you can. Like this type, all you need to do is you use the Excel to get the mean, get the standard deviation, and then go through the same process. The mean you get here, you call it the X bar, and this one is the population mean. Then sample standard deviation, you can get it from here as well, and then go through this process, same formula to get it, and then when you get your answer, compare your answer to the critical value. If it's bigger, you reject. If it's not bigger, or if it's equal to or bigger, you reject. If it's not, then you don't reject. So guys, are you sure you don't have any question for me? Hello? Yeah, no question. So now, let me round up by taking you back to your classroom. Okay. Remember to finish the homework we have for the week. Homework 9 and homework 10. Do your projects, and on Sunday night I'll make this final exam available for you. Okay, if you don't have any questions, then I have to say have a good night. Yeah. And enjoy your holiday. Because like I said, this is the last time you've seen it. There's no class next week. Okay? All right, all right. Have a good night.